Welcome back to my YouTube channel, and today we're going to solve this question that says show that the general solution of a differential equation, that is x squared divided dx equals to x squared minus xy plus y squared, may be expressed in the form x equals to a exponential of x over x minus y, where a is an arbitrary constant. So in this question, it's a differential equation, and this one is a first order homogeneous differential equation. So our equation, as we have said, it is x squared divided over dx is equals to x squared minus xy plus y squared. Now we need to separate dy dx and this x, so that means we divide both sides by x square, and this gives dy over dx is equivalent to x square minus xy plus y square over x squared. Then we define y, this y here, as v of x, and therefore if we differentiate this y by product rule, it gives dy over dx is equivalent to, you odd v constant, you differentiate x with respect to x, and that gives you v times 1, which is v. Then you hold x constant, you differentiate v with respect to x. So that means in our original equation, whenever we have a dy dx, we replace with v plus x dv over dx, and wherever we have a y, we substitute it with v of x, and that now gives v is v plus x dv is equals to x square minus v of x square. Reason being, we have the x is squared because of this x, then y is v of x, so that becomes v x square plus this y is squared, so we square these components here, and that gives v square plus x square divided by x square. Then after that, we need to separate the variables. That means we need to sort out this x and bring it on this other side, and we sort out the dx here and bring it on one side. That means we separate the variables. We are separating v and x, and upon separation, you can first divide both sides with x square, and if you do that, then you subtract v on both sides. Then that gives you x dv over dx equals to 1 minus 2v plus v squared. Then again, you divide both sides by this. You divide both sides by these components here, and that gives you dx over x is equivalent to dv over 1 minus 2v plus v squared. So that means we can integrate now both sides. Can integrate both sides, and that is the integral of x, that is the integral of 1 over x dx, which can be written as dx over x integral is equivalent to the integral of dv over 1 minus 2v plus v squared. And if you simplify this denominator here, that means this can be written as v minus 1 everything squared. So integrating this side, that gives the natural log of x. Then if you integrate this side, it means that will give us minus 1 over v minus 1 plus the constant of integration, constant c. And this negative here, if we manipulate the denominator part, now this we do with this negative, this now becomes 1 over 1 minus v plus c. Then this is equivalent, now natural log of x is equivalent to 1 over 1 minus v plus constant c. So if we eliminate this natural log on this side, that means we express this to the natural log, and that means eliminating this natural log here, it will remain with x, which is equivalent to the exponential of this function here, and the exponential of that function, if we apply the laws of logarithms, that now means we can simplify, split this and this, you can split this and this. So the law in application when splitting this one is simply the addition law of logarithms, and that means if you apply the addition law of logarithms, now this becomes x equals to exponential of c multiplied by the exponential of 1 over 1 minus v. Then if you let exponential of c to be a constant, let's say constant a, then we replace this v with y over x, and now that becomes x is equivalent to exponential of, that is x is equivalent to a exponential of 1 over 1 minus y over x. And now if we simplify this part by algebraic simplification, that means we have 1 minus y over x. If say this is 1 over 1, then we solve by fractions. Then we take the reciprocal of this part, that will give us x is equals to a exponential of x over x minus y. So thank you very much. Thank you for watching. Thank you for listening, and thank you for being good audience. We'll see you soon. Remember to subscribe, like, and share. Let's grow together.